welcome back to AGT STEM. Today we're going to be watching a video about iron. So, without further ado, let's hop to it.
The thermite reaction, which is the reaction of aluminium and iron oxide, is used to make iron, and because aluminium has much stronger bonds to oxygen than iron, that the reaction produces an enormous amount of heat. And you can use this for welding pieces of metals together.
So this is a thermite.
So you use some iron oxide and aluminium, and you can make two pieces of metal stick together. Wow.
Mixture. It's a mixture of iron oxides and aluminium powder, and we're going to do some redox chemistry, and we're going to generate some molten iron, which will hopefully stream from the bottom of the flower pot. So here you can see the black particles of the iron oxide, and the silver particles of the aluminium powder. So we get some heat on this. We start an instantaneous redox reaction. So the aluminium and the iron oxide swap oxygens. So the aluminium will become oxidized, the iron will become reduced. Hopefully we'll generate a lot of molten iron, which should come from the bottom of the test tube of the flower pot.
All right.
I don't think it's a test tube.
Right.
Now there's a story about students in Berkeley that some students decided, or a group of students decided, to do a practical joke.
I find it funny that he was using a sparkler to light the iron and aluminium.
On a tram, which of the sort that has one door when you go in and another one where you go out. So a big group of students queued onto the tram and got into the front, and there were enough of them so that they could actually come out at the end, at the other door, and form a loop. So they were just going round and round and round, so the tram couldn't leave because there were just more and more people getting on.
Could have ran out of tape.
And while they were doing this, other students went down under the tram and set off two thermite reactions and welded the wheels, metal wheels of the tram to the steel rails, so that when the tram tried to...
I feel like that's not even a practical joke anymore.
to leave, when the students eventually stopped going round and round, it was firmly welded to the tracks and couldn't move at all.
It's gone out.
Talk me through what's going on, mate.
So instantly the thermite reaction starts, and you can see that it's so hot it's burnt a hole through the bottom of that terracotta flower pot. If we go in close now, Brady, you can see all that really quite nice molten iron. Now that's so hot that the iron itself has melted and it's formed this really quite big goo in the bottom on the sand.
Do you encourage these sort of practical jokes?
No. Our students are far more responsible.
So as soon as the firework or the sparkler hit the top of the thermite reaction in the top of here, it started off the instantaneous redox reaction. So this was where the metals were fighting for the oxygen. The aluminium won that battle, and the aluminium came out of this reaction as aluminium oxide. The iron was reduced, and we can see that now in the bottom, which is really hot. So I'm not going to get too close, but you can see all of this really, really hot.
I couldn't tell that it was so hot. It's definitely not like bright orange.
Hot iron. So the iron was molten, it dribbled out through the bottom of the flower pot, and it's now cooling.
Well, so it didn't dribble out the bottom of the flower pot.
Well, it smashed its way out of the flower pot.
Well, you can say that iron is in my blood. It's in your blood as well. It's iron that gives hemoglobin, the red pigment in your blood, its red colour.
So the reaction we saw was about 5 minutes.
So the iron in our blood is, the reason our blood is red is because of the iron.
Minutes ago, and the iron that was generated is still glowing red hot, and you can see it's fused itself to the bottom half of the flower pot, which it broke in its tumultuous step forward.
It is an absolutely central molecule element to life, except for crabs, which use copper. but you'll have to hear about that later.
So iron's a really, really abundant metal, which is used as lots and lots of structural materials. So you can see lots of pieces of iron around some of the racking, and even in fact, some of these pieces of equipment have got high iron contents. They've got other elements mixed with them to form alloys, like stainless steel.
I have an extremely long-standing interest in its chemistry. And in particular, I made one compound of iron, so-called iron tetracarbonyl, which had 4 groups round it, and everybody had expected that it would have a shape like one of these, shaped with tetrahedron like that, whereas in fact it turned out that it had a much more irregular shape. The 4 groups were arranged like this. And so ever since this, every time I hear the word iron, I get quite excited.
So this is iron wire.
He was abusing the iron. We need to call the Iron Protective Services.
Okay, and you can see this is a very small wire. It's 0.2 of a millimetre in diameter, and you can see that the shiny material underneath is iron that hasn't undergone oxidation. So this is where it's been protected from the oxygen in the air. Now if we look at the iron at the top, we can see this looks really familiar, especially because it looks like the rust that we might find on the bottom side of some of our cars. So here's some iron oxide on top of the iron.
The very first chemical experiment I did chemical reaction was with iron. And I think the same is true for many generations of school children. I heated up iron and sulphur together and made iron sulfide, sort of blackish solid. But then we put acid on it and got a terrible smell of bad eggs. And this was my introduction to chemistry. And I really loved it.
Thank you so much for watching. We'll see you next time. Stay smart. Bye.